student at the College of Education. And today we'll talk a little bit about ggplot. Before we started, I wanted to mention that this workshop and the whole event is sponsored by Data Services, which is a new department at the library. Data Services provide a lot of services for faculty, students, and staff regarding their data, their research. They can help you find data, analyze it, and manage it, and also visualize that data. Their services range from consultation appointment to workshops in class and out class. You can request a workshop from them. They can come to your class and teach your student. If you would like, you can request that through the website. Also, the data services support a lot of software, including SPSS, Data R, Atlas TI, Tableau, and Qualtrics. They can, as I mentioned, they can provide all type of support, one-on-one consultations or workshops. So to begin, I'm going to talk a little bit about the visualization. We have two types of visualization. The first type that most of us use in reports, which basically we are not looking to any farther than explaining what's going on in the data. We have data, we look into the patterns and the percentage or count, and we present that type of data. This is very simple. And the other type is we look farther than descriptive analysis of the data. We go to add a lot of statistical analysis to predict patterns and correlations in our data. So since we know now the two types of data, let's have a look at basic graphs. So this is the first type, which is a very simple descriptive for our data. We have the X and Y, and if you see the code is one line, all what we have to do just see the distribution of this variable. We have lending and borrowing. The second type, basically, we're adding a regression line, which is basically we're moving from describing our data to add more of prediction of what's going on in this data and how can we use visualization to predict patterns. And if you can see the code almost 5 lines. So now we know the two types of visualization. I have a data. I decided that I want either describe my data or I want to draw a conclusion of what's going on in this data for further analysis. After I know these two facts about my goal of this visualization, I move to data measurement level. This is the basic foundation for quantitative work in general and data visualization in specific. Why it's important? Because it will be the foundation of choosing what type of visualization is suitable for our data. So data in general are two types, either qualitative or quantitative. Terms might be different from field to field, but this is common. It's either numeric or categorical. Categorical, we have the binary, with some field they call it dichotomous, some field call it dummy variables. This type of data takes only two values, either 0 or 1, fail or pass, war, no war, gender, male or female. Then we have ordinal data. Ordinal data is very popular in survey research because we have the Likert scale. We have, for example, flight class. We have like first class, economic class, business class. So that's ordinal because the data somehow has an order. Also, academic ranking, military ranking, that all ordinal data. Then we have nominal data, which is very simple. It's the name of whatever. So for example, if I have a variable that is countries, that is a nominal data. Same thing, names of presidents or attack types, those all consider nominal data. Now we move a little bit to numeric. So we have two types, discrete and continuous. Discrete is basically a number of, like we cannot plot it in the number lines. It's either a student in a class, or a number of resident visit, or number of patients in one hospital. That's a discrete. A continuous, it can range to not specify numbers, like for example, age or GPA or temperatures. And within continuous, there is also specific differentiation. It will matter if you do complex analysis, but the main thing is that you know continuous and discrete. So for example, in continuous, we have ratio and interval. The main difference is the interval does not have a starting point, and also the zero has a meaning into it, where ratio is the opposite. For example, if someone has in their account, in their saving, zero, that means basically they're broke, they don't have money. So zero actually has a meaning, right? But if I am saying the temperature is zero, that doesn't mean that it's not cold, it's freezing, because zero has a meaning. So that's the main difference. But you really don't have to worry about the differentiation between interval and ratio until you have a very complex analysis. Okay, so now we know the data measurement level. Can I manipulate this? Yes. Do I have to? No, unless it's necessary, because sometimes you need to manipulate the data level. How can I manipulate this? For example, I collected data on age. I asked people how old they are, right? And I got the variable of age measured in continuous. It's a numeric variable. I can manipulate this variable and make it categorical by dividing the ages into groups. For example, from 21 to 25, from 26 to 30, and so on. In that case, I change the level of the data from numeric to categorical. And sometimes there is actual purposes for doing this. It's not just a random reason to do that. But the most important, when you do data manipulation, just be aware of what comes next. So if you are, let's say, if you're running a regression and you say, yeah, I know, like linear regression take a continuous variable, but if you switch the data from continuous to categorical, you can no longer run a regression, linear regression. You have to change the analysis from linear regression to either ordinal or logistic, depends on the variable. So awareness of the measurement of the data is very important. So enough now with the measurement. Let's go to this nice piece that I truly like and appreciate. The author of this piece actually allow people to modify his work, and if you go online, you can see a lot of modifications to his piece. This is just suggestions on how to choose the visualization based on either the purpose of your visualization or the variable. Let's take a look into relationship. For example, if I have data and I want to look into relationship, if I have two variables, I'm going to just choose scatter plot, right? But if I'm going to add another variable, I can do it by either inserting color or inserting size to make a differentiation in the third variable that I'm adding. The same thing with distributions. Histogram is well known as the default for checking for distribution, but sometimes the variable has a lot of data. So in that term, I can decide whether I want the histogram to be a bar histogram or line histogram. So this is some type of suggestions that the author had, and if you go online, as I mentioned, you will find a lot of modification to his work. Now let's talk about ggplot. What is ggplot? ggplot is a package built within R, and the concept of ggplot is based on an old concept called the grammar of the graphics. What is the grammar of the graphics? It's a belief that the same way we talk, the same way we organize our sentence, the graphics is like that. There is a syntax, there is a grammar for these graphs that we can use to build a nice graph. For example, we have this basic graph that has lending and borrowing. If we check the line for code in ggplot, it's made of this syntax. First, we initiate the functions. We tell R, start a ggplot for me. And the first argument is the data set, which is in this case, ILL, which is a data that it's a preset data, but I modified variable to be relevant to this workshop. So that's the first argument in the syntax. Then a comma, then we set what is the X and Y in our data. So that's the second layer of the grammar. The third one is the shape of the graphs. In this case, I choose points because it's appropriate for two continuous variables. So that's the basic grammar of ggplot. Data set, X and Y, shape. But is that all what ggplot has? No. ggplot is built on 7 grammars. The first 3 is the most important grammar. You cannot produce a graph without it. It's basically the basic of the basic. So we have data, we have aesthetics, which is the X and Y, and we have the shape of the graph. Then if I want more stuff, I can add another layer, which is the theme. The theme is different, and there is a lot of options out there. It's basically your style in your graph. How would you like it? There is a lot of preset themes, and also you can customize your own theme. Then we have another layer, statistic. As I mentioned, if I want to go beyond descriptive visualization, I can add layer of statistic that can do regression line, plotting the means, and stuff like that. Then we have the coordinates, which is the space where the data is plotted. Because sometimes I don't need my graph to be vertical. I need it in a different shape, so I can use that layer to modify my graphs. Then in some cases, I need multiple plots. I don't need one plot. In that case, I add the 7th layer. So as I mentioned, the first 3 are the importance, and the other 4 are optionals for your preference and your goal of the visualization. So now I'm gonna share R to begin working on the script that I had few examples. Okay. So the first thing we need to do in R is to install the package ggplot, then to read it into our environment. So once you do that, you load the data set that you have. In this case, this is my data set here. And as I mentioned, it's a pre-set data set. I just modified the variable's name to be relevant. The first thing that you want to do is to read the structure of your data. In this case, it's through the function str, which is abbreviation for structures. Why do we need to do that? Because sometimes different software read different variables based on whatever software you opened the data for before. For example, especially with Excel, this is like a very common problem. Excel tend to change the format of the variables into dates sometimes. So even though you know your data set, you know what variables that you have, it's better to check how R read your data. So we run the structure functions, and we can see that we have numeric variable lending. It's the level of this variable is numeric. Then we have affiliation, which is character, categorical variable. And we have other numeric and one categorical, which is gender. So let's now go to the first basic graph. As I mentioned, this graph has the function to initiate the graph, data set, which is in this case our data set that we uploaded. Then I specify the x's, the x and y, which I want borrowing and lending, and I choose the shape I want it points. That's the basic plot, right? But sometimes I want to modify it. So if you want to modify any layer, do it inside the parentheses. For example, if I want to work on those dots, I should work inside those parentheses because I am dealing with the shape of those graphs. One famous function, it's alpha. What is alpha? Alpha is like how dark or how light are those dots. Alpha range from 0 to 1. For example, in this, if I run this code, I can see the dots are not as dark as it used to be. And if I change the value to 0, we will not be able to see the dot. And if I change it to 1, which is the default, it will be so dark. I can also change the color. If I don't want my dots to be black, I can change it. But at the same time, remember, every changes you make should be within that layer. So I want the color to be pink. I can, inside the join points, I can add color pink. You can customize it whatever color you want. And for example, if I want red, I can just type red and it will change it for me. Not only color, I can also change the shape. R comes with a set of shapes that you can choose number, and you can check the list of all shapes that R has. For example, if we pick shape 2, we can see that instead of the dot, we have triangle. I want the shape 5. It will be another shape, and so on. Can I do another customization to this point? Yes, which is the size. Here, if you notice, I changed the shape. The shape is set to 0, which is the square, and I set the size 8. I can also customize the size how I want. I can set it to 4, for example, and I will have this shape. So this is 2 continuous variables, lending and borrowing. What if I wanted to add a third variable, but I want it to be set to alpha? And as we mentioned before, alpha is how dark or light your data point. What if I want this feature to be set based on the affiliation of the request? I can say alpha and I add affiliation. And one thing to remember, because we said ggplot is based on layers, so if you want to add any variable, it should be in here within the x and y. But if you want it within the shape of the data, you have to give credit. Imagine like Jim Point saying, you know what, I know this variable belongs to you, that's why I'm adding this here. because basically they're giving credit like this is taken from here, because the original place for variable should be in the second layer. So I run this code and I see that the color of the points, it's dark and light based on the affiliation. We can see the students are the darkest and the admin are the lightest. So let's, as we mentioned, adding variable, this has to be in the second layer from here, right? Go back to our original graph, the basic one, lending and borrowing. I want to add affiliation, but I want it by color. So if you're adding, if you have continuous and continuous, and you want to add a third variable, there is few ways to do it. You either differentiate it by color, like in this case, I just specify after I add my X and Y, I add color and I put the variable affiliation. So I run this code and I see that now I have the lending and borrowing divided by the, plotted by the affiliation. We have admin, faculty, and student. Okay, what if I want it by size? I can do that. And instead of color, I just change the code to size. Can I do multiple, like can I do the same thing in one code? Sure, I can, let me copy this. And this is the beauty of ggplot, is that you can build so many layers within one code. So now I want to add color and size. We can see that. So what if I want shape? So adding a third variable can be by color, by size, or shape. So we can see that circle for admin, triangle for faculty, square for student. Now we add the third variable and we differentiate it. We use the shape to differentiate between each category. Can I make it size, shape, and color? Can I go crazy in one plot? Yes, you can do that because ggplot is a very powerful, flexible tool. So what if the third variable that I want is not categorical? What if it's continuous? Also, you can do this by adding the same way. You just add the continuous variable. In this case, it's average of requests per day. So we have lending, borrowing, and average requests per day. And we can see now we have the dots and we have a scale for a continuous variable. The darkest is the darkest and the lightest color in this visualization. So what if I want to add statistical component to my graph? As I mentioned, we add another layer, and every layer that you add, you make sure that you add the plus sign. So right now I add GM smooth, which is the confidence interval. So now we have the line, and we have this shaded area, which is the confidence interval. Again, this statistic layer is optional if you want it. So now we talked about plotting continuous variable and adding a third variable, categorical and continuous. What if we want to go crazy and plot 4 variables at the same time? We can do that. So first, I want to tell you a little bit of the difference between color and fill. So color, usually you can change color either from the join points or from here. And color is the border of whatever shape that we choose. Like in this case, this is the line of the shape. The fill is basically what is inside. So in this case, I choose the fill of the shape to be the affiliation. And I choose the shape and the size and the alpha. If I want to add another variable, we add it from the second layer. So we have borrowing, lending, that's the X and Y. Then the third one is affiliation, and we differentiate that variable with fill. And now we want to differentiate another variable, but we want it by color. And we want gender. So in this case, we have two continuous variable and two categorical variable. Borrowing and lending for continuous, affiliation and gender for categorical. If we run this code, we have this visualization. So gender, because we specify that we want to differentiate gender from affiliation by the color, which is the border of the shape. So female, the border of the circle will be pink or orange, this color, and male will be the blue. So for example, here, this dot that we have here, we know it's a student because the fill is in blue. And we know it's a female because the border of the circle is in pink. So now we have 4 variables plotted in the same graph. I think there's a question here. No, okay. So far, so good.
It looks like Ming has a question.
Okay.
Actually, I have a question. Since you're asking for a question, can I ask a question?
Yeah, sure.
What does this say borrowing? You have this 100, 200, 300, 400. What does this number refers to? And you have lending 10, or these intervals. What these number refer to? Are they refers to the number of times of borrowed or
Yes.
people?
Yes, time, numbers like a count. So in this plot or the one, you mean this one?
Yeah, what are these numbers, let's say 10, 15, 20, 25, 30, 35? These are the people or the number of accounts that borrowed or lended.
Yeah, so this is like a fake data set. It's not like real. So this is the number of requests. So in this case, we have a negative relationship between lending and borrowing. So as the borrowing go high, the lending go down. So for example, we see the highest number here is 35. It's the number of requests. So does that make sense? Like we're just seeing what is the pattern in lending and borrowing? Is there any correlation between the two process? So in this case, in this fake data set, we have a correlation between lending and borrowing, which is a negative relationship. Once goes up, the second go down, if that makes sense.
But you introduced the category like student, admin, and faculty. And if you say that, describe that in a narrative, how would you describe that? Say the blue thing and say student, blah, blah. How would you describe that?
Yeah, I can say, like, for example, in this here, we see like a higher number of lending requests coming from students, but also we have a lower number of lending requests coming from admins here. But at the same time, admin, that we have a higher request from admin in borrowing, if that makes sense.
Lending request. Okay. Lending.
Yeah, and this data set is fake, like it has nothing.
The lending, would the request would be from the outside the Seton Hall student, would not be from inside the Seton Hall student.
Yeah, but this is like a fake data set, like it doesn't have any meaning to what's going on in real life. It just like I used it to make stuff relevant, if that makes sense.
Okay, okay.
But it's not like nothing of this data is real.
Okay, thank you.
Is there any questions?
Is that the end of the presentation, Samah?
No.
Okay.
Okay, so
Awesome. So yeah, you keep going, and that's great. Thank you.
So ggplot has a lot of shapes, and for example, all what we did, we were like just working on the geom point. If you go to the list of functions in ggplot, there is tons of shapes that we can use and play with. For example, we have text, geom text. So in this case, I want lending and borrowing, but I want affiliations, not dots. I want it text. I can run this code, and I can see instead of the dot, I actually had the text that is in the data, which is student, 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 faculty, faculty, faculty. What if I wanted gender? The same code, and I just changed the label to gender. And we can see female, female, male. And I want to re-emphasize on the thing, on the same point. When we use variable in the geom layer, we have to specify it's coming from the second layer. One of the stuff that most student faculty use is logging the data. Most of the time we have data that is not normally distributed, and we need to figure out how to normalize the data, and we can do this with logging the variable. In ggplot, we can do that by adding a third layer, which is the statistic. So up to this code, we're in the third layer. Then I add the plus sign, and I add scale x log, which is a function, and scale y log. I leave it empty because I don't have any specification. I just want the log. So let's see the graph without logging the variable. So I'm just going to run it up to here. So this is the graph before logging the variable. Now I'm going to run the graph with logging the variable, logging the x and y. We can see the distribution now is a little bit defined better than the first graph. So this is the two functions in statistic layer is somehow common and important in data visualization. So now we talked about points, we talked about text. Now we're going to talk a little bit about bars. So the same exact syntax, the only difference is instead of geom point, we can say geom bar. So I would run this code, and I can see that I have now bar plot, and I have it by affiliation and also by gender. What if I don't want it stacked on top of each other? I want every bar to be stand alone by itself. I can do this by changing the position. As we did with the points plot, every changes that we make, it has to be in that layer between those parentheses. So now we want to change the shape of the bars. We don't want them stacked on top of each other. We change them from the geom bar. We set the position dodge. We run this code. We can see now we have separate bars for every category. For admins, and it's male and female, faculty, male and female, student, male and female. Sometimes we have a lot of data in those variable, like a lot of values. We don't need vertical graphs. We need to change the shape in order to fit the data. In this case, it's not a lot. We're fine with this, but I just wanted to show you how can we do it. We do it from adding another layer, which is coordinate flip. And we can see that it flipped. And here I added color in the bar, and it's just surrounding the shape. Again, you can choose whatever color that you want, depends on your reference. Sometimes we want variables to be plotted in the same graph, but it's in multiple plot. That can be done in ggplot by another layer, which is this one here. So I specify it. If you wanna create multiple plot, for me, create it by gender. So we run the code, and we have male and female in separate graphs. Is that okay so far? So that's what I have for today. I actually underestimate the time. I thought that we're going to take longer, but we're done here. Is there any questions?
Any questions about R in general? Seton Hall has a subscription to LinkedIn Learning that you may want to check out if you haven't. There's a lot of great modules in there for R, Python, Power BI, and a lot of the things we'll be presenting this week.
Well, thank you so much for coming. Yes, Louisa, you have a question?
Yeah, first of all, thank you so much for presenting. It was great. I would just love to know, and I think it would be helpful for a lot of people too, what kind of tips do you have for people who are interested in learning R? Is there anything that you did that you felt like was helpful?
So I did recognize something that I had with my friend recently. So she's been trying to learn R for so long. And every time we have a session, she's always upset that everything is intimidating, there's so much, she forget the code, which is reasonable because R is a new language. And when you learn a new language, you must have mistakes, and that's very common. And we finally got to the point that I said, okay, let's try one package. Just focus on one package, which is ggplot, and she was so happy with it. She felt less intimidated, and she was like, I think I love R now because she focused in one package. So I think one of the tips that I would like to say is just focus on packages. Like, for example, if you're into managing data, you do a lot of cleaning, a lot of modification, computing variables and stuff like that. I would focus on packages that do stuff like that. R comes with a base functions to manage data, but tidyverse is a good start. It's a very excellent package for managing data and compute variables and transform variables, so stuff like that. And if you're into visualization, of course, ggplot is super powerful package. So I think if you try to focus on what you need from R, that would be very helpful.
Okay.
Thank you.
That's great. Thank you, Samah, so much.
Thank you for coming. I truly appreciate it.
Yeah, great to see undergrad, graduate students here, some visitors from Scotland, Professor Iannarella. So thank you, everybody. And we'll see you tomorrow. If anybody's coming, the next event is Chelsea's presenting Power BI at 2 o'clock. All right. So have a great day.
Thank you. You too. Thank you, Samah.
You're welcome.